So we'll just do a couple complete the square problems before I do like an integral. So completing the square is another thing that you did in pre-calc. This would have been in the quadratics unit, which depending on what order your teacher did stuff in would be like at the end of quarter one, beginning of quarter two. So when you did all the quadratic stuff. So to complete the square, you're going to keep the first two terms. And then what you need to do is figure out what that third term should be. So like ignore the 10, pretend it's not a 10. It's what do we want that third term to be so that it'll be a perfect square trinomial so that you can write it as something squared. And so what you do is you take this middle coefficient, divide it by 2 and square. So it is divide by 2 and square. So 6 divided by 2 would be 3, and then 3 squared would be 9. So we want a 9 there, and I usually say, you know, put parentheses around that. I always say give it a hug. Give that a hug. And then you, believe it or not, you're not allowed to just go around changing the problem. You're not allowed to do that. So you have to turn the 9 back into a 10. You have to maintain the integrity of the problem. So I'm going to have to put a +1 out here. So 9 plus 1 is 10. And then the whole point is that you can write it as something squared plus 1. This would factor into x plus 3 times x plus 3. So it would be x plus 3 squared plus 1. So that is completing the square. And I'll do one more before we actually like do an integral. So if you have something out front, like a coefficient, like this one has a -1, you have to factor that out, but only from the first two terms. The reason you don't worry about the last term is we're gonna change it anyway. Like see how this one was a 10, we changed it to a 9. You don't need to worry about that last term because we're gonna adjust that anyway. So we're just gonna factor a negative out of these two terms. So that'll make it a positive x squared and a minus 8x. So I just factored out that negative, but just from the first two terms. And then we want to complete the square. So it's divide by 2 and square. So, hey guys, what are we going to add on at the end here? You want to take 8, divide by 2 and square. So what are we going to add on here? Good, nice job, perfect. 16. So whenever you square something, it's always positive. So when you do the squaring part, it's going to always end up being a plus. So it will always be added on. Now, here's the thing, though. It is actually a -16, because if you were to distribute this negative back into there, you would get a -16. So we have to turn a -16 back into a +5. So if you think about your number line, like if you're way over here on the number line at -16, what are you going to have to add on to get all the way back to +5? Here, I'll draw you a number line. If you're down here at -16, you need to get back to a +5 because that's what the problem was. Good, perfect, nice job, guys. We're going to add on 21. You're not allowed to just change the problem. So like you have to maintain the integrity of the problem. And so the whole point, like why on earth are we doing this? The whole point is you can then write it as something squared. And so what's in these parentheses here would factor into x minus 4 times x minus 4. So it's going to be x minus 4 squared. So anyway, let's do a couple that have an integral. And just as a heads up, these complete the square ones do turn out to be arc something. It's going to be arc sine, arc tangent, or arc secant. That's how these ones turn out when you complete the square. So just be anticipating that. That's how they go. All right, so we are going to figure out what we want to add on here. And you're going to divide by 2 and square. So what will we add on for this one? You're going to take 10, divide by 2 and square. Good, nice job, guys. 25, perfect. I'm going to give it a hug. And then I have to turn a 25 back into a 34. So we are going to add 9. So I kept the integral and I kept the dx. I'm going to keep them for one more step as well. Again, because I didn't actually do the antiderivative. And so the whole point is, so you can write this as something squared plus 9. And so what's going to go in those parentheses? That's like the whole idea is that you want to write it in this format. So what's going to go in there? Like if you factored this, it would split, but both terms would be the same. Good, nice job, guys, perfect. You guys are on top of it today, nice. So x minus 5. So it's going to be arctangent because we don't have a square root here. So a is going to be 3. 3 squared is 9. U is going to be x minus 5. And the derivative of x minus 5 is just going to be dx. And so I am going to skip that step that I was telling you you're allowed to skip if you want to. As long as you recognize it's going to be arctangent, you can just go ahead and write out the answer. Arctangent has that 1 over a out front, so it's going to be 1/3 arctangent u over a plus c. All right, so we're just going to try one more. And so already before I even touch this problem, it's going to be arcsine because there's a square root and there's not something else in front of it. So this is going to be arcsine, just as a heads up. So when you go to complete the square, and this is going to get kind of long here, we're going to have like a gigantic square root under here. You're going to have to factor out the negative. So I'm going to take the negative out of both of those terms. So it will be a positive x squared plus 4x. Now 4 is kind of weird when this happens because when you divide by 2 and square, you get 4. Like it's still just going to be 4. And it looks like you didn't do anything, but 4 divided by 2 is 2. And then when you square that, 2 squared is 4. Now we have to adjust. And this is actually a negative 4. So we have a negative 4. I need for it to be a 0. There was nothing here. This is like plus nothing. So if we have a negative 4, I'm going to need to add 4 to keep that the same. And all of that is underneath the square root. All of this is taking place within that part of the problem. So I guess if you even wanted to do it off to the side and then put it back so you don't have to draw the square root every time, you could. I didn't want to confuse anybody, but so I'm going to keep writing it every time, but it's all underneath of there. All right, so this is going to be integral 1 over, and then let's see what we have got here. I'm actually going to put this 4 in front so I can have 4 minus the other stuff. So this will be 4 minus something squared. And if you factor what's in the parentheses there, it's going to be x plus 2. So again, I just wrote this 4 out front so that it could be 4 and then minus all that stuff. So a is 2. 2 squared gives you 4. U is x plus 2. which again is nice because that derivative is just dx. And as long as you recognize it's going to be arc sine, then you can just write out the answer. Now, arc sine does not have this fraction out front. So it's just going to be arc sine of u over a plus c.